Welcome back to Study Guide Forum. Today again, we'll be looking at some of the tests like we have been doing in this our preparatory class. In this case, we are looking at how to test for cations. The cations we have here, we have series of cations. We have calcium, zinc, lead, aluminium, iron 2, iron 3, and copper. Here we will be testing and we will be giving you details on how to test with what you will expect when you are testing with sodium hydroxide, and this is what you get when you are testing with aqueous ammonia solution. So in let's start from here. In sodium hydroxide solution, that is sodium hydroxide solution, what you expect here is that adding sodium hydroxide in drops will give you white precipitate, which is insoluble in excess sodium hydroxide. Now, for the zinc ion, adding the sodium hydroxide will give you white precipitate, which is soluble in excess sodium hydroxide. And then this other one, you notice that in lead also, it give you white precipitate, which will be soluble in excess sodium hydroxide. Now, lead lead will give you aluminium will give you white precipitate, which is soluble in excess sodium hydroxide. Now you know something here. Do you notice something that all of them are white precipitate soluble in excess? Three of them. These three of them that are soluble like that is because they are amphoteric oxides. They have onto amphoteric oxide and they have two characteristics. That means they can act like an acid and also act like a base. So you notice that this other area we have soluble. Then in our subsequent classes, we are going to decide to talk about how we can separate these oxides, ions from a solution. We're going to look at it in this our unique class so that we'll be able to know how to handle them. Now to this other one, iron 2, it gives you green gelatinous precipitate which is insoluble in excess sodium hydroxide. Now for iron 3, it gives you reddish brown gelatinous precipitate in excess is insoluble. Now we come down to copper. Copper will give you blue gelatinous precipitate which is insoluble in excess. All these things are what you are likely to find out. That means when you're using sodium hydroxide, you are likely to confirm the presence of this calcium. You can also use sodium hydroxide to confirm the presence of iron 2, iron 3, and also copper 2. But you cannot use sodium hydroxide to confirm the presence of this. You have to do another test, which you are going to look into. Just relax. So we come over to this other end, and we aqueous ammonia. With aqueous ammonia, calcium aqueous ammonia in drop and in excess, there is no visible reaction. There's no precipitate, everything remains the same. Now, in zinc, you have white gelatinous precipitate, which is soluble in excess, giving you a colorless solution. It will give you a colorless solution. Giving a colorless solution. Gives a colorless solution. Now with lead, you have white precipitate insoluble, and with aluminium, you have white precipitate in drop and insoluble in excess. Now look at it. That means with aqueous ammonia, you can separate zinc ion from lead and aluminium ion, but with sodium hydroxide, it's not possible to separate any. You cannot identify any of them because if you look at here, all of them has white precipitate, but here only this one is soluble and this other one they are not soluble. Now we can also go down to iron 2. This will green gelatinous precipitate which is insoluble in excess. Then we come down to iron 3. We have reddish brown gelatinous precipitate which is insoluble in excess. To copper, aluminium will be copper aqueous ammonia will give you pale blue precipitate with copper and which is soluble to give you a deep blue solution. In fact, this solution, deep blue solution, you cannot mistake it. You cannot miss. This is the first test analysis that I I learned early in life. For the first one, in fact when I look at that color, I don't mistake it at all. So you cannot mistake this anytime you see it. So even if you go to my video, some of the videos I've done, you notice that I did a test on this, a really practical test on this, how to identify copper, where I did have it in short and also in a video, right? So now we know that if you look at this now, I want us to capitalize on this area. We can, if you look at this, you can identify this, identify this one with what we have here. In some exams, they might give you these two things together, although we'll come into that in another video so that we'll be able to know how the tricks of setting some of these exams, especially now we're talking about alternative to practicals. Now, you look at this one, I want to capitalize on this. In this area, you find out that with this, we know the difference. Calcium does not show any visible reaction. That is fine. Okay. This other one will give us white precipitate, which is soluble in SS. This other one, we know everything about it. But here, there's something I want us to rest on this for a while. You see, I've given them a special place. Lead ion and aluminium ion. Two of them, they have unique character. With sodium hydroxide, you notice they are the same. In aqueous ammonia, they are also the same. Now, how do you separate this? Now, there's something about these two ion. This one with chlorides. Chloride ion will give you white precipitate. White precipitate to give you white precipitate. This white precipitate, when you heat it, when you heat the white precipitate, it will be soluble. And then when it's cold, it will come back again. That is one of the ways of separating it from here. You understand? But this one, with chloride, it will give you no visible reaction. No visible reaction with chloride. Everything, because aluminum chloride is soluble. For this one, lead chloride is not soluble. So that's one of the ways of differentiating them. All right. Thank you so much for being part of the class. I hope you enjoyed the class. We'll have more exciting time. We will have more exciting time. More videos are coming to help you understand this so much. Thank you so much for coming this far. I want to, in fact, I want to, you know, read your comment to find out how you feel about the classes. Subscribe, like, and then share. Now, if you want to really talk to us direct, you can visit our Facebook page, which you will see in the description channel column of this channel. In the description column there, you will see our Facebook page. Visit the page. You can also get a number to call us, so you can interact with us. And then, thank you so much.